What's up, YouTubers? Today we're going to be talking about ScatterPlots. ScatterPlots is a topic that y'all have been doing for quite a while now. Today will be two things. Can you remember the parent functions, and can you put stuff in our calculator? Okay, so be sure you have your calculator around. Just kind of follow along with me. Okay, the first four, actually, you don't need the calculator for because we hopefully will remember some things about our parent functions. First thing is that we're going to look at the change in x and the change in y. So we're going to look at what's happening there. So our x's are going up by 1 every time. Our y's are going up by, looks like 15 every single time. 15, 15, 15. So a graph that has the same change in y over change in x, we call that a linear graph. That's the linear parent function would be y equals x. Change in y over change in x, that's the slope. Okay. Number two, we look at the same thing. It's plus 1, plus 1, plus 1 all the way. This would be plus 6, and then plus 8, and plus 10. So if you look there, well, my second difference is going up 2 and up 2. The graph that has that is a quadratic. Number three, if you look, if we were to graph this, you would have 1040, and then 1100, 12250, 13625. It would look something like this. The graph that looks like that is an exponential. And last one, number four, if you were to graph that, you would get this picture, which is the square root. So on a couple of those, it'd be best to plot them, and you can use your calculator, and I'll show you how to do that in a second. Or you can just know some information about the parent functions. Okay. Number five wants to know whether it's an exponential or logarithmic. So this is the time that we can use our calculator to use. You're going to press Stat, and we're going to go to Edit, and we're going to go to L1, and we're going to put all those x values in. So we have 0, 2, 4, 6, 8, and 10. And then my y2, or my L2 rather, is going to be all my y's. So 214, 105, 51, 25, 12, and 6. All right, then go to y equals and go. Be sure this is highlighted. If it's not highlighted, just go up there and press enter. And then we're going to press zoom 9, and we're going to hopefully see a picture. And we see a picture like that. So now what we have to remember about our parent functions is that for number 5, for example, an exponential graph, growth looks like this. A decay looks like that. And a logarithmic, our other choice, is like that. Well, our picture most resembles that, so that's an exponential, and I'm going to say decay. All right? So once again, the steps, if you want to see your ordered pairs, be sure you go to Stat, and we go to Edit, and then we put them all in, and then if you want to see them, be sure your stat plot is on. So you go up here, press enter, and then we're going to press zoom, and then go down to zoom stat number 9. And that'll get you to see your picture pretty and all that stuff. Okay? So that's pretty much all you got to do. Take your order pairs, put them into your calculator, and see what the graph looks like. If it's, upside down parabola, then it would be quadratic. And if you actually want to get the actual equation, you go to stat, and then we go over to calc, and you pick whatever one the equation looks like. So if we have a line, go to number 4. If you think it's a quadratic, go to number 5, and I'll give you the quadratic regression for a parabola, essentially. Okay, so I'm going to kind of give you the answers to everything else, and maybe you can work this by yourself and pause whenever you need a second, okay? So number 6, if we plug all those in, you're going to get a picture that kind of looks like this. So the one that best looks like that is the natural log. 1/2 x looks like this. Negative 1/2 x squared is upside down parabola, and square root of x plus 1 would be over here. So that doesn't fit that graph or those points, so the answer is A. Let's see, number 7. Go ahead and plot those points. So if you plot those points, let me see if I can get the picture here. Yeah, nope, sorry. Yeah, you plot those points. Once again, we did stat edit. We put our L1, we put our x's. Our L2, we put our y's. Then we got the equation using stat calc and then linear regression. So stat calc and then linear regression. I think that's number 4. And so you should get, y equals ax plus b and it tells you that A is at 1.234 and B is 5.574. And then C, you can either take 7 and put it into the equation right there, or you can just look at 7, it's about 14 of where it would be. Okay? Um, Number 8 is going to work the same way. You could do that. I would, for this one, since they give us the equation, I would just take 1 and plug it in for every x and see which one they give you. For A, well, for any of these, when we're talking about the equation, sorry, A equals the first or the starting amount and 1 plus the rate to the t. So our starting amount is not going to be 1.013. So A is out and D is out. So then it's just between B and C. And the answer is C. Okay. And the last couple, number 9, I think I have the answers here. Yeah. Number 9, it's quadratic. There's the equation. I even have a screenshot of my calculator for you. There's the equation. And then obviously the highest point is 3 comma 145. Number 10, if you do the work, the answer is going to be 10 or 21.1, excuse me, 410. So the answer is D. And then number 11, if you look at, yeah, just go up by the x's, the y's are going down, roughly about the same point. So you can guess and check or put it in the calculator. And then number 11, if you look at it, it's an exponential. All right, so a lot of calculator stuff. Unfortunately, I can't really do it for you. If you don't have a calculator, come on in. We can work it together or do whatever. All right, see y'all later. Bye.